Model for process definition. The process model contains three elements. Number one, input or inputs of the process. Two, output or outputs of the process. Three, the process or task. The process orientation helps the organization in identifying all the inputs, documenting them, and having a control over the quality of the product by having a control over all the inputs and the process parameters. Input of the process. The various inputs required for any process are bill of materials, specification for each material, requirements for inspection for the incoming materials, procedure for the receipt of the materials. Output of the process consists the products or service to be delivered, documents to be delivered, the specifications for all of the above, method of measurements of verifying conformance to the specifications, criteria for acceptance or rejection.
ETX model or the entry task exit model is the most popular process model. The value adding process here is called task, and the new items in the diagram are entry and exit. Entry is conditions to be satisfied before the task is undertaken, and exit is conditions to be fulfilled before the task is considered as completed. The Saburaj 6S model for process improvement. The 6S here are study, streamline, simplify, standardize, synergize, and strengthen.
Study. The current performance level of the processes triggers improvement. It could be that the best found, both internal and external, cycle time achieved,
customer feedback or complaint, employee feedback, customer waiting time, hassles of
employees or customers, and etc. Therefore, it is important to study the process and document the details as necessary. Streamline. It means that the process should offer the least resistance to motion in the organization. Quite often, some processes cause delay or hassle, leading to problems either to customer or to the employees. Therefore, it is important to first document the current sequence of event and then eliminate the unnecessary or non-value-adding processes. For instance, before embarking on TQM, the CEO of the organization was formally issuing the test and calibration reports under his signature. Due to his busy schedules, the issue of reports was getting delayed. Therefore, by including appropriate quality checks, this non-value activity was dispensed with by delegating the responsibility to middle managers. Simplify. Simplifying processes improves quality. One has to formulate simplified procedure for carrying out the task without increasing the cost and compromising the quality. For instance, the organization was making 3 copies of the test reports. One for the customer, one for use as a duplicate, and if the record was not received by the customer for any reason, and the third as a record. By analysis and by making appropriate arrangement, it was reduced to preparing 1 copy for issue to customer, and the same was stored in electronic media for record purposes. This step reduces the work, save paper, and above all, simplify the work.
Standardize. Standardization essentially permits performing the process in the same way by every employee at all times. Therefore, it requires a documented procedure. Synergize. No process is a standalone activity in any organization. A process may interact at least 2 other processes, the customer and supplier processes. Therefore, it is important that the effect of revision on other processes is checked. Strengthen. During this phase, a number of activities are carried out. First, educating and convincing the process owners, their customers, and suppliers. Second, periodic counseling and assuring that the new process will perform better than the old process. Third, monitoring the results and confirming that the process transition has occurred. The employees are confident that the process is processed as documented.
Supply chain management. It is a task of optimizing all activities throughout the supply chain so that the products and services are supplied in the right quantity, quality, customer, time, and at optimal cost. SCM involves the following activities: demand planning, manufacturing planning and scheduling, supply planning, and transportation planning. Demand planning. Process that schedules manufacturing orders with production capacity, a combination of material requirements planning and capacity requirement planning to create optimized and constrained production plan. Supply planning, process that meets customer demand based on available inventory and transportation resources. It includes distribution requirement planning needed to replenish inventory at branch warehouses. Transportation planning, process that schedule, load, and deliver shipments to customer while considering the delivery date, mode of transportation, carriers, and etc.
Kanban system. What is Kanban? The Kanban system was developed by Mr. Taichi Ono, the Vice President of Toyota. It is formed to achieve objectives that includes reducing costs by eliminating waste or scrap, try to create work sites that can respond to changes quickly, facilitating the methods of achieving and assuring quality control, and lastly, design work sites according to human dignity, mutual trust, support, and allowing workers to reach their maximum potential. Kanban stands for Kan, means card, and Ban means signal. The Japanese refers to Kanban as a part of movement system that depends on cards, boxes, and containers that take parts from one workstation to another on a production line. The essence of Kanban concept is that supplier or warehouse should only deliver components to the production line as when they are needed, so that there are no storage on the production area. A Kanban is a card containing all the information required for the jobs to be carried out on a product at each stage, along its path to completion and which part are needed to subsequent process. These cards used to control work in progress, production, and inventory flow. A Kanban system allows company to use just-in-time production and ordering systems, which allow them to minimize their inventories while satisfying customers' demand. Consists of the set of these cards, one being allocated for each part being manufactured, next, travel between proceeding, and lastly, subsequent process.
Withdrawal Kanban. This is also known as move cards or conveyance Kanbans. Whenever a component is to be shifted from one production part to another, this type of Kanban are used for signaling. The card is connected to a stipulated number of parts that are taken to the working place where they are needed. When these parts are used, the cards are returned as a signal for sending the same part with the same number back. It specifies the kind and quantity of product which a manufacturing process should withdraw from a preceding process. Production Kanban. It is made up on an exhaustive list of all the things needed by the part that is completed. This brings in the requisite materials and parts along with the information that withdrawal Kanban includes. Production Kanban allows the production system to start with the production and also explain the things that should be produced. It specifies the kind and quantity of product which the preceding process must produce.
Cellular manufacturing. A cell is normally configured for speed and minimal material handling and can reap substantial benefits in cost savings, time compress, and inventory reduction. It is a group of workstations, machine, or equipment arranged that a product or sub-assembly can be processed progressively from one workstation to another, without having wait for the batch to be completed or requiring additional handling between operations. If a cell may produce one type of component or sub-assembly or a product, single-piece flow can be implemented in cells in a natural way. Cellular manufacturing and work cells are the heart of lean manufacturing. It increases productivity and quality, and also it simplifies the material flow, management, and accounting. A work cell is a work unit larger than an individual machine or workstation but smaller than the usual departments and assembly lines. Typically, it employs 3 to 12 and 5 to 15 workstations in a compact management. Cellular configuration can be in the form of straight line or U-shape, but equipment containment within the cell and workstations are normally configured in close proximity to compress time and space. The advantages that many companies derive from linking processes in cells is that it improves quality and reduces rework cost because the material produced in one operation is tested for fit.
What is single-piece flow? Piece flow, also called continuous following, refer to the way of product moving from one step in the process to the next, moving them efficiently by planning workflow based on the product its need instead of organization or equipment.
Prepare yourself for oblivion! Galecon!
Flow manufacturing versus batch production. The opposite if one-piece flow is large production. Although many companies produce goods in large lots or batches, it builds delay into the process. No items can move on to the next process until all the items in the lot have been processed. The larger the lot, the longer the items sit and wait between processes. Larger lot production can lower companies' profitability in several ways as given. The lead time between customer orders and delivery of products is lengthened. Labor, energy, and space are required to store and transport the lot. The chances for product damage or deterioration are increased. One-piece flow production can help in solving these problems. Here are some illustrations that will make clear how single-piece flow is more advantageous. Batch and queue processing. From process A to process B to process C, where lead time is 30 minutes plus for total order and 21 minutes plus for pairs piece. Continuous flow processing, process A, process B, and process C, wherein 12 minutes for total order and 3 minutes for pairs part. The difference between the two, in both the batch and continuous flow processing, it takes 1 minute for manufacturing one part, and in the batch processing, 10 parts are manufactured at a time. Therefore, it takes 10 minutes for processing the process in A, it takes 10 minutes in B, and then send it to the process C. Thus, the first piece will come out in the 21st minutes, and it takes 30 minutes of fabricating 10 pieces. It takes only 12 minutes for the total order when we adopt one-piece flow as given in Figure B.